So this is a little overview of the material in the first part of chapter is it 25 or 26 on electrochemistry and the little paperback book. So I started by making a copy of a picture here, just going with what they say below. And this is a cadmium and a nickel battery, sometimes called a NiCad battery. So this would be cadmium, and this would be nickel. In the solutions here, you probably have a cadmium nitrate and a nickel 2 nitrate, like that. What happens is the cadmium, well, first of all, if you had this chemical equation, cadmium plus nickel 2 nitrate like this, you'd expect to get cadmium nitrate and nickel would be released. The cadmium, it'd be released with 0 charge. The cadmium has 0 charge. The nickel here has +2 charge, and the cadmium has +2 charge here. So from left to right, you can see the cadmium went from 0 to +2, and the nickel went from +2 to 0. And in order for that to happen, electrons had to leave the cadmium and go to the nickel. So technically what happened is this cadmium turned into cadmium ions, and it released 2 electrons. And this nickel, the nickel ions, picked up the 2 electrons and became nickel metal, like that. Well, this in a battery, you do the same reaction, except that you're trying to make the electrons have to move through this wire. They go in here, come across, come out. So the current flow is actually flowing in this direction. And the electrons are moving over to this electrode where the nickel ions that are in the solution pick them up. So this reaction here happens at that electrode, and that is called the cathode. Reduction always occurs at the cathode. The cathode will have a negative charge, and the nickel then will be attracted to it to pick up electrons. So this electrode will actually get thicker because the nickel ions will be plating on this electrode. On this side, the cadmium is losing the electrons, and so electrons are, as the cadmium ions form here, the electrons that the atom lost move through the wire in that direction. So this is called the oxidation reaction, and that occurs at the anode. So in a battery, you always have a cathode and an anode. The cathode will be negatively charged, the anode will be positive. So the cathode attracts cations because the cathode's negative and cations are positive, so it attracts cations. So you can always remember the cathodes attract cations and anodes attract anions. That's why it's called that. Attract anions. And at the anode we have oxidation occurring. And at the cathode we have reduction occurring. All right, so that's a little overview of how a battery works. Now, of course, as the nickel ions are reduced to nickel metal, then we have a buildup of NO3- because they're not doing anything. So what they do is they start moving in this direction, so the NO3- goes that way. And on this side, you're going to get a buildup of cadmium ions, which are cadmium +2. So these cadmium ions are going to move in this direction. So what happens is the ions can change sides to maintain a balance of charge. I don't know if you've ever taken apart a battery, just took a hammer and screwdriver and tore it apart to see what was inside, but if you did, you'd find a moist paste. So this is called a wet cell because they got solutions in them. A car battery is a wet cell, but flashlight batteries and radio batteries and stuff are called dry cells, but they work the same way, except that this is moist, it's just not liquid. And there's a little piece of paper, if you take it apart, that separates the two components, and a little piece of paper serves the function of the salt bridge. All right, so that's an overview of how a battery works. And that should be enough information for you guys to figure out how to do question 2 and 3 on this page. All right, these cells are called, batteries are called voltaic cells. They create a voltage. All right, this is the first little movie, is section 1 of this chapter, or it's actually section 2 of the chapter. Section 1, I'm not going to go over, you can read it. And we've already talked in our chat sessions about how to add up the voltages, but just to remind you, to find the voltage of a battery, you go to the reduction potentials in the back of the book, right here. And whichever of the two parts of the battery that has a higher reduction potential will be reduced. So let me show you here. Nickel. See if I can find it. Nickel's right here. This nickel is plus 2, has a reduction potential of negative 0.257. And the cadmium is up here, has a reduction potential of negative 0.4. So negative 0.2 is a bigger number than negative 0.4. So that means that this one will be reduced and the cadmium will be oxidized. So you would change the sign on this, then add the two together, so you would have a negative point. I can just show you really quick, perhaps. So you'd have a negative 0.257 plus, oh, that's a negative sign. How do I get a negative sign here? Negative 0.257. Then we're going to add to that the cadmium, which is 0.4025. So the battery voltage for this cell would be 0.1455. So you just add them together. You don't need to worry about the number of electrons being even. You just add up the potentials to find the voltage of the battery. All right, so that's the end of this little video.